So in these videos, we started to replace different part of Kubernetes with bash script just to understand better what's going on under the hood. And in the last video, we realized that the scheduler itself is very simple if you have just one node, right? It's easy to schedule to one node. That's not the trick. And we try to replace this one with a bash script. And today we will have a closer look to the kubelet. And we will check that how can we replace some of the functionality with something else, with something which is more simple. And this is not etcd, this is definitely a containerd. So that's what we need to understand, right? We have seen an example that we can just connect to the API server with simple curl commands. But what's going on this? So the title of this video series is Kubernetes is not magic, but even if Kubernetes is not magic, something in kubelet is definitely very close to the magic. So in this video, just let's have a closer look what's going on. For the scheduler here, we just, to understand what's going on and what are the requests here, we just turned on the audit log. So how can we understand what's going on here? How can we communicate with containerd without the kubelet, but with something else? Well, first of all, let's start a containerd. So I have some containerd here. It's nothing more, just starting the daemon. So, okay, this is started. And we can see that we have some socket here. So most probably this will be the socket for the communication. And if you go to the same directory and go to the kubelet and check how did we do. So this depends on the Kubernetes is the hard way, just it's a slightly more simple parameter set what we are using here. And you can see that, this is definitely the containerd daemon, and it's connected to the containerd to do the hard work. So, okay, let's connect to the containerd. So I guess it should be gRPC because in the Western world, everybody uses gRPC, or at least it's very popular. In other words, for example, Apache Dubbo is more popular. So what can we do? We have a gRPC curl, and let's try to connect to this Unix daemon. Okay, I need some more permission. And, this is not TLS at all. Interesting. Okay, so the first problem is that this reflection API, it's usually not turned on. So I don't know exactly what are the services, unless I have the source code. And I have the source code. So this is the containerd. So let's just try to understand what kind of protofiles are here. Oh, a lot of protofiles actually. But this is API service. It should be the service layer. So let's go to the API services version v1, and let's try to call this one with gRPC. Okay, plain text Unix containerd, and I need a proto, I guess. And let's go with this version proto. Okay, I have to call the service. So let's check what kind of service do we have. We have a version/version. The service name is version, the method name is version. It's empty parameter, which will be easy for me. And this is the name, or the namespace of the version. So let's call the version. Okay, it looks good. I defined the version proto, but the problem is that I need this gogo proto, because this is referenced from the version proto. That's the problem, that we need this one. So let's go back and try to find this one. Yes, actually we have these types. So I think if I set the import path, import, we need first of all the services API, API services, right? API services version v1, and we need the import path. I'm not sure if this import path is, and it works. So I set the import path of the version proto, I set the import path of this GoGo proto, and after that I just used the version proto and I said this is plain text and the unit socket, and I just called the version method endpoint and it worked. So let's check what can I do beyond the version proto. So version, okay, let's go to, these are the services. Oh, we have snapshot, namespaces, laces, images, different containers actually. So maybe I can just start the container, right? And in that case, I don't need the kubelet at all. Well, the problem is that even if we found this socket, it's slightly more tricky because this is not what kubelet uses, because this is a very specific containerd socket and a containerd specific language. And kubelet uses a different language. This is the so-called container runtime interface, which is also available in exactly the same context. So if I would like to behave like a kubelet, I need to understand this interface, not this one. So let's check what is this container runtime interface in more details. So first of all, if I go to the Kubernetes resource, we can check. Okay, let's go back to the. So this is the containerd. I can just start it, or I can check the arguments, and you can see that there is some subcommand that information about the containerd config. It seems to be interesting, so let's check what is this. Oh, containerd config, right? Containerd config. Yes. So we can check the default config. Oh, this is the default config. And if I check the default config, you can see that, oh, this is one plugin. This is the container runtime interface. This is the language that Kubernetes can speak. And all of the other container runtimes should use this language. So, a lot of parameters. So let's check how can we talk with this Kubernetes container runtime interface. So to find the proto files, we need to check the source of the Kubernetes itself. And we are trying to find the CRI proto files just to use them. Oh, we have one. So let's first start with the alpha. And let's reuse the gRPC URL from here, but now it's slightly different because we need the import path of this one. Okay, the GoGo can be useful, we will see. And instead of version proto, we need to use the API proto. You can see that this is API proto. And I don't know exactly what is the service name, but we will check it very soon. So this is the service definition. Let's check what's inside. Okay, so the package name is runtime v alpha 2. And this is runtime service. Oh, and we have a version. So let's try to call the version here as well. So runtime v1 alpha 2 runtime service. Runtime service slash version. Okay, this is, the import path is not perfect. This is better. Okay, the problem with this GoGo proto that in our case, let's check one more time this one. Okay, this seems to be a full relative URL So maybe we need the vendor directory here, not the full URL. So let's go back to here. And I think it's in the other directory. It's in containerd slash vendor, hopefully. Oh, yes. And it works well, right? It's the version, but now we are talking with using the CRI, the container runtime interface. And you can say that, okay, why do we need this one at all? And that's definitely an option if you would like to use just something which supports the CRI. That, for example, the CRI it's exactly this project. You can just start similar to the containerd, but it doesn't contain anything else, just the bare minimum, which is required to communicate between the kubelet and the container thingy. So what is this container thingy actually? So let's go back to the containerd and go back to the API services, and let's try to understand how can we start a container. So here we have containers v1. So containers v1, and only thing what I need is just check the proto and check how can I create a container. Service containers, get list, update, delete, create one. Very good. Message container. So this was supposed to be used for create and everything. I think we have labels, ID, that's all what I can understand. And okay, this seems to be very tricky because the exact specification is just any. I don't know the exact specification here. So it seems that something is runtime specific. I'm definitely interested about what is this runtime. So let's go back to the containerd and try to understand then what is this runtime. So let's check again the containerd config default runtime, and oh, it seems that we have the runtime, which is runc. Okay, maybe I don't need to use this magic at all, but I can just use from the bash the runtime itself, right? So what is this runtime? So we have two type of specification. This is the Open Container Initiative specification. And here you can find the specifications, and there are two important specifications, the runtime spec and the image spec. Image spec is that how can you pack all of the container layers and everything, and runtime that how can you start any process in an isolated way. You can use C group, you can use Linux network namespaces under the hood, or you can use any kind of virtualization, but the runc uses the good old container technologies, which depends on the C group and Linux namespace isolations. So the runc implements this one. And it turns out that it's very easy to start with runc because we have a command line interface for runc, not just a library. So let's try to create a container with runc. So runc, what do we have here? Checkpoint run, that looks good. Init, oh, initialize the namespace and launch the process. No, this is not something what I'm interested in. Spec, create a new spec file. Okay, so I have the spec file. Yes, config.json. So it looks good. I don't have terminal, I'm pretty sure, because I would like to start something which very simple. For example, the bin sleep infinity, just sleep forever. And okay, these are all of the capabilities, limits. Oh, I need a root file system. That's interesting. I don't have a root file system right now. Prots. Okay, we have a few mounts which will be mounted. I'm very happy to have all of them. We will have devices. We will have the namespace isolation. That's very nice. And read-only path. So it looks good to me. The only problem is that I need a root. So let's try to get the root. So this is which one is managed by the containerd itself, but we don't have containerd right now. So let's export it from the with the help of Docker, but actually you can use any other root if you can create a root. Oh, was it? Oh, it was quite fast. So let's try to enter this one. Okay, these are the layers in the image, and I think I'm interested about this one. So let's go to the root, and it was in the Alpine / this one. Yes. Okay, so I have an Alpine Linux root, right? Everything is here. It looks like a real Linux distribution. And I have the config, which defines that the sleep will be executed. Okay, just let me check if this sleep is in the bin and not in the user bin. Oh, it's in the bin, in the root. So let's try to run a container. Oh, it looks good. It's like a running container. Just, yes, it's running. So are you on drugs? Okay, I can see that the running container. I think I can check even the processes inside the container. Yes, it's running. So I definitely started this container and it's just running. Well, I provided the root file system my own because I didn't use any containerd or any magic, just the bare minimum runc, which is nothing more, just creating the process itself in an isolated way. Well, I can use any other OCI runtime spec compatible way to start. There are some other options, kata containers and so on. But runc can be a start. But in fact, runc is not a magic at all because there is a lot of very smart things, but at the end of the day, it will just start the process inside a Linux C group and Linux namespace isolation. So maybe we can just replace everything here with a simple process execution from the bash script. Yes, we just removed some very important functionalities, but at least we can achieve something which is way more simple and we can understand how does it work. But this will be continued in the next video.